All right, here we're on section 11.2. This is on transformations and translations of parabolas, basically moving them around. So the basic graphing transformations of y equals ax squared, performing graphical and horizontal translations, applying vertex form, and then modeling with quadratic functions. Those are our objectives in this section. So the basic transformations of graphs. So if we have a y equals ax squared where a is greater than 0, then as a increases, the resulting parabola becomes narrower. And so as we can see here, this is 1 half x squared. Then if we go here, we get x squared. And here we have 2x squared. And then if we end up here, it'd be a 4x squared and keep getting bigger. So it keeps going in and getting narrower on each side as we increase the a. Now, when a is greater than the 0, it never goes below the x-axis. So it's always going to be above. Now, the complete opposite for when a is less than 0. So it's always going to be below. And instead of getting bigger, it's going to get smaller as far as, if we have on a number line, here's 0, here's -1, and over here is -5. As we get smaller, what happens is it's going to go in. So it's going to go in this like this. So here's like the -1/2, then we have a -1, -2, this would be a -4. So as we get smaller and smaller, then it's going to get narrower. Okay, so it's kind of the opposite of how it is. I mean, the numbers, if you just look at the number without the sign, it's getting bigger, but with the sign, we're actually getting smaller. All right, so the graph of y equals ax squared is a parabola with the following characteristics. The vertex is at 0, 0. The axis of symmetry, therefore, is at x equals 0. It opens up if a is greater than 0 and down if a is less than 0. And it's wider than the graph of y equals x squared if 0 less than absolute value of a is less than 1. It is narrower than the graph of y equals x squared. And if the absolute value of a is greater than 1, okay? So that's going to be what it is. So again, that comes back to here, it's going to be wider if it's going to be, between 0 and 1. So if we think of that wider, well, that's half. That's between 0 and 1. Then if we went to a fourth and so on, it's going to keep going down and down and down, and it's going to get really wide. And same thing here. The absolute value of it is going to get, keep going wider and wider and wider. All right, so what we want us to do here is compare the graph of -4x squared to the graph of x squared. Then graph both functions on the same coordinate axis. All right, so we know they're going to be both opening down because they're negative, and it's going to be more narrow for this one than this one. And so this is x squared. Well, I guess they're not both opening down. This is a positive x squared. I was thinking they were both negatives. Never mind. So that's a positive, so it's going to open up, and this one's opening down. All right, so we have this one is opening up, this one's opening down. This is more narrow because we have that -4, the absolute value that's going to be, greater than the a of 1, and so it's going to be pushed in, and so that's what it's going to look like. So we have a wide one opening up and a narrow one opening down. All right, so the graph of y equals x squared is a parabola opening up with a vertex 0, 0. Okay, so that's our kind of our blue line here. Then all three graphs have the same shape. The x squared plus 1, and x squared minus 2. Now, this plus 1 and the minus 2, that's going to be shifting the original parabola x squared. And when we shift plus 1, that means we go up 1. So we go up 1 unit and everything goes up 1 unit. So basically we can just redraw it, go up 1, and that's what it is. Now when we have -2 here, that means we're going to subtract 2 off of whatever this value is. And so that means we're going to shift it down 2 units. And so everything will be shifted down 2 units, and then we can redraw that. And these shifts are called translations because they do not change the shape of the graph, only its position on the graph. So we're translating it up or down when we add or subtract after the function. So that's our function, and we added or we subtracted, so we either went up or we went down. Now, the graph of y equals x squared we know is a parabola opening up with that vertex. What if we have something like this? So instead of the x squared, we have x minus 1, the quantity squared. So what happens here? Well, if we remember back to, I think it was the first video I did, when I did this one, we said we shifted it to the right, okay? And what we see is, if this is our original parabola, y equals x squared, if we move it to the right, that gives us the x minus 1, the quantity squared. And we can look at that in a table. So if we have x here, that gives us, these values for x squared. And if we use, now what's going to happen is because we're shifting to the right, we need to move more numbers to the right. So we're going to have more positives. And so then we get, the same numbers, but we're all to the one space to the right. Okay, and so that's how that's going to work. So we're translating it, we're shifting to the right. And so when we have something inside of wherever the x part is, the x minus 1 in this case, and we square that, we've shifted to the right. Now if we have x plus 2 squared instead, what's going to happen is we're going to shift it 2 units to the left. Okay, so that's going to be how the horizontal translations work. It's going to be the opposite sign. So a minus 1 here. And the reason why is because this is actually x minus h and squared. And so that h in this case, when it's a 1, it means we're going to shift it 1 unit to the right. And when we have here 2, that's going to be x minus a minus 2 squared. So that minus 2 means we're going to go left 2. Okay, so that's kind of more reasoning why it looks like that. Oh, I guess they actually use x plus 2 here. So we've talked about this one already. So that's really what it's doing. It's shifting it 2 units to the left. And again, it's because it's the x minus h, the quantity squared. So to get this to be a plus 2, we have to have x minus a minus 2 squared, because the minus a minus 2 is plus. And so that means we've shifted it negative 2 units. So we've gone left 2 units. All right, so let's stop there and we'll come back for some more.